Hello guys, this is the MEPtutor, and in today's video we have to solve this problem. Rose and Jack, like the main characters in Titanic, are on a cruise when their ship tragically sinks. They are thrust into the freezing cold ocean. They see a large wooden door floating on the surface of the water and wonder if they could survive if they both lay on the top of the door. They estimate that the door measures 2 times 1 times 0.12 meters to the cube. The density of the salt water is 1027 kilograms per meters to the cube. The first question is, what does the density of the wood have to be in order for Jack and Rose to stay above the surface of the water? So first, we're going to draw a diagram with all the forces involved. And here we got the y-axis, and this is the positive side of the y-axis in this direction. Here we got the door here, and the forces that are acting here are basically the total weight of the door combined with the weight of Jack and Rose, and the force that will be counteracting the weight will be the buoyant force. The buoyant force, okay, must be greater for them to stay above the water, or at least equal to the total weight of the door, Jack, and Rose. And we are looking for the minimum buoyant force. So we're looking for the case where they are equal. So the sum of the forces on the y-axis, which is the only axis that we are considering, because it's the only axis with forces in this problem, will give us that. Let's put it here, the buoyant force, and here the weight force. Okay, the weight force must be equal to the buoyant force. Okay, what is the weight force? Is that the weight force will be the total weight of Jack and Rose, which is 120 kilograms, plus the weight of the door. The weight of the door is the volume of the door. If we multiply this gives us 0.24 meters to the cube times the density of the wood. So this is 0.4 meters to the cube times the density of the wood. And let's say that this is equal to the volume of the door. Okay, this multiplies to the gravity, and this must be equal to the density of the water times the volume of the water times gravity. So we have gravity on both sides of the equation, so it is irrelevant. We just simplify with the gravity. The next assumption that we must do is that the volume of the door is equal to the volume of the water displaced. Why? Because we are looking for the maximum density for the door. So all the volume of the door must be involved. So for that, all the volume of the door will displace the same volume of water, and not more than that, because there is no more wood, and they will get Jack and Rose more wet than they were. So that's not ideal. So the volume of the door is equal to the volume of the water. So having that assumption, we have all the variables. We got that 120 kilograms plus, okay, the volume of the door times the density of the door is equal to the density of the water times the volume of the water displaced. And we know the density of the water. So we multiply here, 1057 kilograms per meter to the cube. So the only variable is the density of the wood. And that is basically 1057 kilograms per meters to the cube times 0.24 meters to the cube minus 120 kilograms divided by 0.24 meters to the cube. So we put that on our calculator and we find that the density of the water of the door is equal to 127 kilograms per meters to the cube. So this is the first question solved. Now let's solve the second question. If the door is made of pine and the density of pine is 750 kilograms per meter to the cube, can one of them survive? Well, definitely both of them cannot survive at the same time because the density of the pine is larger than the maximum density of the wood for both of them survive. So both cannot survive at the same time. But let's see if one of them at least can survive. Now, to do that, we are going to find the maximum mass that this density for the door can stay floating, right? So let's say mass, let's call maximum mass, plus the density, the volume of the door is the same. Now the density is 750, and that is equal to 1057 times 0.24. The volume of water displaced is the same. So we just replace this variable. The maximum mass is equal to 0.24 meters to the cube times 1057 minus 750 kilograms per meters to the cube. If we put this on our calculator, we observe that the maximum mass for this density of the wood is roughly 66 kilograms. And 66 kilograms is a larger mass than the mass of Jack and the mass of Rose. So we conclude that one of them can survive. That is the solution for the second question.